Okay, so today we're going to be looking at the properties of liquid nitrogen. Nitrogen is a very common gas. The atmosphere of the Earth consists of about 80% nitrogen. So the air that you're breathing right now is the same as what's in this bottle. This is called a Dewar flask. It's specially designed to hold the liquid nitrogen as a liquid. It's very cold. The temperature is minus 196 degrees Celsius or minus 321 degrees Fahrenheit. So it's extremely cold. That's why you can't touch it. It would give you frostbite instantly, and that's why we have these gloves, and I have some tongs here to handle materials. It's held in this specialized flask. The blue here is evacuated of air so that you have a really good thermos so that the liquid nitrogen stays a liquid. All right. Now, the interesting thing is, because it's a gas, you can turn it from a liquid back into a gas, and the volume of a gas compared to a liquid is enormously greater, about almost 2,000 times larger in volume. There's a simple relationship between the volume of a gas and the temperature of a gas. If you have a volume at a cold temperature, if you increase the temperature, the volume also has to increase. It's called a direct proportion. So at a low temperature, you have a small volume. At a high temperature, you have a much larger volume. All right, and you can demonstrate that by cooling off the air in balloons. Here's a balloon that's already started to warm up. Okay, so as I pull this out of there, this is full of liquid nitrogen. What's going to happen is the balloon will expand as it warms up. Okay, so the balloon expands in size as it warms. Here's another balloon. You can guess how many I'm going to be able to pull out of here. So far that was 2. Here's a third. There's 4. These are fully inflated balloons, as you'll see as they warm up. 4. Here's 5. 6. 7. 8. All right, I only had 8 this time. I've gotten as many as I think 15 balloons in there before, which is quite a large number. You can also demonstrate how much gases expand when they turn from a liquid to a gas by putting them in a container and closing the container. A lot of people try this with Coke bottles. It's really not a great idea to close off a bottle for that reason right there. If you close it off, it will explode and it could cause you a lot of harm. And this one is pretty big, so it goes pretty quick. There you go. You have to keep in mind that the temperature of the liquid nitrogen is so low that the temperature of the countertop is like a hot griddle to it. Let's see if we can warm that up a little bit. There we go. So the hot griddle effect causes it to boil instantly when it comes in contact. Let's see if we can get that back out of there. There we go. Causes it to boil instantly. That's why when I pour it onto the floor in front of you, it does this. It's like pouring water in a hot griddle. It makes it boil instantly. So it's really quite interesting. Another interesting feature is that it is very, very low viscosity. That means that it flows very easily. So I'm going to put some in this flask that has some little bits of paper in it so you can see it flowing. And I'm going to compare it to the water. And now the top of this glass is not as cold as the bottom. I can actually grasp this with some degree of safety. And I can swirl these around and watch how long the liquid nitrogen continues to swirl compared to the water. Start the water over again and the liquid nitrogen will still be swirling around. You can actually see it boiling in there, I believe. Can you hear it? It's a boiling gas. It's a boiling gas. Let's see.
Do you have any solid nitrogen?
Solid nitrogen requires you to decrease the pressure by some large amount so that you can actually get it to turn into solid. Another fun thing you can do with liquid nitrogen is cause things to become very brittle. All right, for example, if we take a nice, beautiful flower here. People get sad about this. I'm not sure why. You take a beautiful flower like this lily, and you dunk that in some liquid nitrogen. Living tissue is made mostly of water, right? Just like we're made mostly of water, the flower is made mostly of water. And so, when you freeze it, you freeze the water, and it's like a big pile of ice cubes. And it doesn't look like a pile of ice cubes, but they're very, very small ice cubes. And so that means that it's very easy to just break it into pieces. Now that's not terribly dramatic, but a little bit more dramatic is if you have a nice racquetball like this one, pretty bouncy. Well, here's one that I've been freezing in the liquid nitrogen. Okay, so a little direct comparison. Yeah, this one is not nearly as bouncy. In fact, it's extremely brittle. And if I grab it with the cryo gloves here and throw it against the wall, you can get this as enough racquetball to do what I want it to do. It's a nice brittle racquetball, a little bit different from the bouncy one. And there we go. Much better. Much better. It's broke into two big pieces here.
Can I have half?
Not bad. So rubber, when it's frozen in liquid nitrogen, becomes quite brittle. And there you have it for liquid nitrogen. It's cold. Okay, so this flask is full of nitrogen. It's a little heavier than air because it's so cold. So I can actually pour it right out onto this candle. And I should be able to put it out. There we go. So nitrogen has no oxygen in it, so it doesn't allow things to burn.